This is a download from the BBC. To find out more, visit bbc.co.uk/Radio 4.
Welcome to the Infinite Monkey Cage, a science show that offers no guarantees due to the uncertainty of the world and the universe beyond it, both statistically and in a quantum mechanical sense. So this all could be conjecture, but good, solid, empirical conjecture nevertheless. I'm Robin Ince.
And I'm Brian Cox. This week we're going to be looking at randomness, probability and chance. So in the absolutely literal spirit of one possible meaning of the potentially infinite set of meanings, both real and imagined, of Infinite Monkey Cage, we took a tombola wheel with all the letters of the alphabet on it, spun it 21 times, noted down each letter and created a title. It was...
The Infinite Monkey Cage. What are the chances of that?
1 over 26 to the power of 21.
Yeah, and I should actually be honest and say that Infinite Monkey Cage wasn't the first set of letters that came up. The first one was actually you and yours, but that seems ridiculous. To help us discuss randomness, probability and chance, we kept with the theme and pulled names out of a hat to decide who the guest would be. And then we decided it wouldn't really work with our guests Lindsay Lohan and the Lord Privy Seal. Anyway, we couldn't get the Lord Privy Seal's number, and also it turned out it's the hat used by I'm a Celebrity, Get Me Out of Here. So Lord Privy Seal's going to be pretty exciting in that locust round.
Well, our first guest has a 1 in 23 chance of having a number one single, a 1 in 47 chance of refusing to go on stage if he has a verruca or a corn, but a 1 in 3,975 chance of saying, the thing about my crystal is that without it, my chakra just goes haywire. Now, as a composer of the new musical of Roald Dahl's Matilda and about to embark on an arena orchestral tour, rationalist musician and comedian Tim Minchin.
Our other guest is one of the few people to have written a book on mathematics and ghostwritten the autobiography of a world-famous footballer, though Bertrand Russell did co-write Principia Mathematica and attempted to ghostwrite an autobiography of Nobby Stiles. It's the author of Pele and Alex's Adventures in Numberland, Alex Bellos.
Alex, I suppose at the simplest level, probability is the study of chance. And I suppose the natural reaction to that is to think, well, chance, completely random events, how can you possibly study it? It must be entirely random. So how does a mathematician begin to study chance?
Well, that's the thing. We can't predict the future for one event. So if there's something that's got a 50-50 chance of happening, tossing a coin, we don't know what's going to happen. But if we were to take 1 million events, toss a coin 1 million times, we can be pretty sure that round about 50% of the time it'll be heads, 50% of the time it'll be tails. So once we have a mathematical language, we can understand, where probability is going to go in the long term.
One of the problems with once it actually gets to numbers, generally, there is something that bamboozles the human brain right from the start. What is it? What do you think it is about the human brain that makes, for some people, the understanding, the comprehension of the meaning of numbers?
Well, there are two things. One is numbers and one is probability. I think lots of people, mathematicians, understand numbers. Lots of people here will understand numbers. But probability is really, really difficult to understand, and mathematicians, it's full of pitfalls and mistakes. So this idea that I might come along and be able to explain probability to you...
It's unlikely to be true.
Absolutely. I was going to say there's a disclaimer. C.S. Peirce, a very famous American mathematician, said, in no other branch of mathematics is it so easy for experts to blunder as in probability theory. So, if I make lots of mistakes, that means I'm a good mathematician.
Tim, your songs, I suppose, many of them are based on irrational beliefs, irrational thought. So, could I ask you, do you have any songs about probability to start with?
Well, I don't have a probability song.
Why?
There's a reasonable chance I'll write one in the future. I've got a song called If I Didn't Have You, which is about love and the notion of fate and soulmates and stuff. And that's got lyrics in it like, your love is 1 in a million, you couldn't buy it at any price, but of the 9,999,000 other possible loves, statistically, some of them would be equally nice. And it also says, I think you're special, but you fall within a bell curve. So, there's, I quite often I find myself saying, what are the odds in my shows to make the point that they're reasonable. They're generally the answer to that question is like you're 1 over 27 to the power of 21 or whatever, that you can find them eventually.
Have you ever written a song and thought, this is a great song, but it's actually statistically inaccurate, and therefore, because that's the thing is you are involved and you write about rationalism, you write about science, you write about, so you actually go, that this is, I've got a problem. I can correctly rhyme this, but this will make it inaccurate, or...
Yeah, there's two things. One, I do have an obsession with making my songs thorough, which is why they're usually about 2 minutes longer than is fun. And And the other thing is I try to keep myself just stupid enough so that I can justify being stupid. Which isn't to say I need to work very hard to keep myself that stupid. I just mean I try to make it apparent that I'm not actually claiming to know anything.
Alex, the history of the study of probability is interesting to me. I know you deal with it in your book.
Well, it's incredibly recent. I mean, it's probably the most recent great idea that mathematics has had, which is this idea that we can sort of predict the future using maths. And it's maybe 500 years old when it was a gambler, in fact, Girolamo Cardano in Italian, who really was the first person to think about probability, about games of chance and gambling in a mathematical way. Because in Rome, for example, people used to gamble all the time, flip coins, and they would think that if Caesar's head came out top, it was Caesar who had decided that you were going to win. So probability and randomness was basically sort of superstition, and superstition died not with Nietzsche or with Darwin, but with Cardano, who said, actually, we can work out numerically what the probabilities are of flicking a coin.
And he was basically looking at the mathematics of gambling, of gaming. So he was trying to work out how to design a game such that you could...
Well, what he was doing, Cardano was probably the most interesting person in maths history. He was a doctor, he wrote 131 books, and he also invented lots of interesting maths, including probability. And he did this because he was an inveterate gambler, and he realized that he was losing lots of money, but there were mathematical ways to actually start winning money. So people would gamble using dice the whole time, and he was the first person really to realize that six-sided dice, the chance of throwing a six is a sixth. And then you can do the maths like that. And that seems to us so obvious. But he was the first person to realise that. And once he realised that, he started making a lot of money and losing it again.
When you talk about working out probability, and when you talk about decisions that you can make and rational decisions, could you, for instance, Tim, live your life by going, hang on a minute, right, I'm just going to work out what is the probability that if I take that action, that will lead to that, and that's the required moment? Or does it become a mathematical exercise in living?
I think I do live my life like that. It's in my nature to try to shed any superstition from any decisions. I actually consciously work on making sure I've got no superstition left. The thing I always try to do if a loved one's getting on a plane is say, I hope you have a crash, but just because I like taking control of what is a very difficult instinct. The toughest superstition I've got that I've had to try to rid myself of is the touch wood superstition. The idea I go, I've never had a car crash. Oh, as if your words can change the universe, but it's so embedded in us that we think we're special. We basically think we're special.
I think it's totally fine to have these little superstitions to make people feel better, to be able to fly easier. It's just when, you lose all your money because you go gambling, it becomes a problem. And, misunderstanding of probability means that people can be conned really easily, and lots of people are conned.
Alex, you tell the story of the way that our natural sense of coincidence and probability can mislead us. And you tell the story of the woman who won the lottery in New Jersey twice in 4 weeks?
Yeah, in 4 months, I think it was.
So 2 lottery wins in 4 months.
Yeah.
And the newspaper...
The newspaper said this was a 1 in 17 trillion chance of that happening. And it was a 1 in trillion chance of any person going and buying one ticket on that day and then going and buying the other ticket. But that's not the way probability works. If there are thousands or millions of people actually buying lottery tickets, it turned out mathematicians did the math on it, so to speak. And the chance of any one person winning 2 lotteries in America in any 4-month period is about 25%. So it's actually quite a probable thing to happen over a course of a few years.
It's completely counterintuitive, isn't it? Which I think is perhaps the origin of superstition and a misunderstanding of many events that happened. You think there's no chance of that. You bump into a friend that you've never seen for 10 years walking down the street in London, you think it's a sign.
Coincidences happen a lot more than you think. And the most famous way of sort of showing that coincidence happen is what's called the birthday paradox, which isn't a birthday paradox at all, which is how many people do you need to have in a room together for it to be more likely than not that 2 share the same birthday?
We're going to get to that.
Yeah, we are. Yeah, birthday paradox. Can we have a little bit later?
Birthday paradox. Later on in the show.
If you'd sung that for just 2 seconds longer, we would have had to pay you royalties. What a pity you missed that.
Birthday paradox. I don't have a problem with that lotto example. The lay idiot's way I think of that is that there's very, very low possibility of thing A happening, but there's loads and loads and loads of things. Therefore, the probability of anything happening is really, really good. In fact, given enough time and enough things, the probability of anything happening is always 1. So any event you can think of will eventually happen, like the existence of human life and all that sort of stuff. But where...
That's not true, that, if it violates the laws of physics.
Let's call these laws of physics theories like they really are.
Why? Why, if time is infinite, theoretically, it's not, but
so let's
if
say,
it was infinite.
So you have a law such as the conservation of electric charge, which is based on some...
I don't have that
So
one. I come from Australia.
So you can't make a negative charge without a positive charge, which is the way we think the universe works at the moment. So that's why you can only create matter and antimatter in equal amounts, because you need to... If you're going to make some matter with a positive charge, you need to make an equal amount with a negative charge. So that would be an absolute law. Then no matter how long you wait...
Yeah, sorry. No, you're absolutely right. A physically impossible thing won't happen if it's physically impossible. If there's a possibility that it's not impossible, then that will happen. But I guess what I'm saying is all possible events will happen over enough time.
Yeah.
Yeah.
That's precision.
Bloody physicists, so can we crack on?
Can we get back to the man, please? This is Radio 4, it's about precision.
The listeners won't know this, but when Brian was explaining antimatter and matter, he was using it both with his fists, as if it were, if Lock, Stock and Two Smoking Barrels had been made by the Open University, you would have been a character in it. We've got matter over here, antimatter over here, and someone, I think, is about to go from matter to antimatter. Thank you, Tim. I am a physicist, you are a minstrel, we can move on.
I'm going Butch for the 3rd series.
Right, now, before we have many more questions, and of course we have to deal with the... what was it we were going to deal with after the next bit? I can't remember.
Birthday paradox.
Thanks, Tim. That was a really handy reminder. Now, I didn't think we would need our regular stand-up mathematician, Matt Parker, on this show, as we already have enough maths, as you can see. But then Matt told me that would lead to an increase of 37% in my likelihood of being attacked by a rook due to the decreasing number of people on stage. I don't know that much about rooks, and I'm only just beginning to understand probability. So for that reason, here's Matt Parker.
I was on a bus the other day, and someone got on, and they were wearing exactly the same T-shirt as me. It was awkward. I thought, one of us is going to have to say something. And he turned to me and just went, "Oh, what are the chances?" Well, no, because we can. We could work this out, right? We need to know the density distribution of T-shirts in the population. We could estimate the average frequency wear rate. You look at the number of people you're close enough to each day to score a match. And if you put all these together, you can work out if our matching T's are significant. It's the so-called statistical T's test. When I did that in the maths department, it went down a treat. We all agreed it was over 95% hilarious, so who's the outlier now? No. But you can work this out. And if you actually go through the numbers, given the sheer number of people you come across each day, I think it would be more amazing if you never bumped into someone wearing the same thing as you. It's like the media coverage last year of Wang Yang's marriage. Wang Yang, who lives in China, married his fiancée, whose name is also Wang Yang. They've got exactly the same name, and they were both born on the 29th of April, 1982. Identical birthday, identical names. It seems amazing. But you can actually look up the statistics on the number of names used in China, which I did. And Yang is actually the 6th most common name in China. There are literally millions of Yangs in China, which is a sentence that gets far more racist the less context it gets. To quote a taxi driver, it's not racist, it's a fact. And Wang is actually the 2nd most common name in China. There are actually, at last count, 93 million Wangs in China. And that's not racist, that's an innuendo. It actually turns out that half the Chinese population draw from just 9 different names. And if you want to factor in the same birthday, the odds of a couple having the same birthday is 1 in 365.24. You're right, sir, the precise number of days in the year. And you can allow for years, and you can actually work it out. And it turns out most coincidences, if you actually crunch the numbers, become a lot less amazing. It was at this point that he got off the bus. It turns out, no matter how many people say, what are the chances, a statistically insignificant number of them actually want to know. Thank you very much.
Lovely moment there as you nearly morphed into Bernard Manning there. I'm not saying that Wang Yang isn't a culturally frequent name in China, but it is.
That's Bernard Manning, isn't it?
Yeah, I said his name again. It was
You did,
one of my clever tricks. Who's this coming? Why, it's my old friend Tycho Brahe. I've got a cold. I don't know where it comes out from now. But we have got Alex. It's your birthday today, isn't it?
Yes, it is.
Yeah. So I think you've got a song for Alex, haven't you?
Happy birthday, Paradox.
That's it. So we're actually going to do a birthday paradox, as you said. Matt is going to go along. Which row? Have you chosen a row, Matt?
Yes, I'm going to start systematically in the corner here and zigzag my way backwards.
Brilliant. Before Matt starts, Alex, can you give us a little bit of the background then? What is the birthday paradox?
The birthday paradox says that in any group of 23 people, it's more likely than not that two people will share the same birthday. And the reason why we call it a paradox, when it's not just mathematically watertight, is that seems a ridiculously small amount of number, and it's incredibly counterintuitive to think that you only need 23 people for two people to share the same birthday. And you actually only need 7 people to be more sure than not that two will have been born within a week of each other. And I think that's what we're going to try and find out.
I mean, it does sound... that is counterintuitive.
Well, there's a pretty damn good chance it'll go wrong, to be fair. I mean, statistically.
Well, let's try this experiment then. So what we're going to do is we're going to pick a random row of the audience, which happens to be the front row over there, because it's easier to get to. And if you just say... You don't need to say the year of your birth, but if you just say the month and day of your birth, and let's see if we can get to 2 having a birthday within a week of each other.
OK.
22nd of October.
19th of September.
September the 8th.
Oh, we're just about there. That's right, yes.
No, we're not there. And it doesn't work if you say we're just about there. It wasn't a week, was it? There was
11 days.
Or was it 11 days?
Yeah. I'm not... Do you know what? I'm beginning to think this Higgs boson thing's a little bit further off than we imagined. I really am.
He's terrible when numbers get under 1 trillion.
Carry on.
Within an order of magnitude is not enough for math.
26th of April.
8th of February.
2nd of June.
16th of October.
Let's double-check our previous October date and...
22nd of October.
Yeah.
And how many was that?
Let Brian work it out.
5, 6, 7.
What a pity. So many people hoping for a rollover with the birthday paradox this week on Radio 4.
No, so it was exactly right.
It's perfect.
Who are you clapping, by the way?
But if we did another group, surely it shouldn't work, because it's only a 50% chance.
Oh, come on, we might as well.
No, but you're right. It's very interesting, actually, because it does seem too good to be true, doesn't it? And that's the thing about statistics.
I'm impartial,
I suppose it clearly works, but go ahead. Let's try it again.
Take 2.
23rd of January.
29th of July.
18th of October.
5th of February.
2nd of February.
There we go.
Can I just say, Alex, this is the best birthday you've ever had, isn't it?
But likewise, if we were to say a date, I think if there are only about 200 people here, it's probably most likely that someone else doesn't share that birthday.
What?
Oh, so if the birthday becomes an observed birthday, then by the act of observing it...
The odds on any 2 birthdays, not the odd that... The odds aren't great, aren't absolutely brilliant that someone will have your birthday.
Yeah, you need, I think, just over 200 people to be pretty sure that someone will have your birthday.
Anyone to celebrate their birthday?
That's not
But no one else's birthday is today.
Isn't it sad? The only person who's actually turned up on their birthday for the show. Everyone else found something better to do.
Yeah, there's bias. There's definitely bias there.
See, but again, that is a fascinating thing, and people I hope we're reasonably interested in the fact that in such a small sample you get that thing that within a week. Now, by understanding probability, if people truly understood probability, would the whole world of gambling collapse? Or would it merely mean that everyone would then go, I have a system? Because you hear with gamblers they have a system. The system is normally going home to their wife and saying, I don't know what happened, I think I was mugged.
Yeah, definitely. People would stop gambling. I've interviewed lots of mathematicians, and none of them have said, yeah, I love gambling. They just don't do it. I mean, what's the point? Or the only one who liked gambling, but this isn't really gambling, is he gambles on the lottery, but only when he can buy every single ticket.
I think wasn't there some research done into this by people who make slot machines about what the payout rate had to be? Because I think everyone who plays a slot machine knows that if they carry on playing it, they'll lose. But there has to be an incentive to play, doesn't there?
Well, the incentive is this sort of delusion called the gambler's fallacy, which is, just say we know we're going to get a jackpot, say 1 in 10, and we don't get the jackpot after 9, then we think, well, it's not happened 9, we're going to get it now. But that doesn't work because every gamble is totally random. But as human beings, we have this memory of what came before. So we think, and that's the fallacy, oh, it's ready to give now, it's ready to give, but it's never ready to give, or it's always ready to give. It's always exactly the same probability. But when we're playing, we tend to believe that there's a pattern behind it, and that forces us to carry on gambling.
We've evolved to see patterns where there aren't.
True.
Especially in vision and stuff. If you're a Neolithic man in a jungle, or woman in a savannah. I don't want to be sexist or geographist. You're sitting there and you see a little bit of orange and a little bit of black and some grass and something. It's worthwhile having the sort of brain that goes, tiger, out of not much data.
Yeah.
We see patterns as much as we possibly can.
It's interesting, isn't it? That I think what we're saying is that trying to behave rationally is almost
irrational.
So counter-instinctual, I suppose.
Well, totally. I mean, there's the interesting anecdote about the shuffle feature on the iPod. People were getting the shuffle feature and they're saying, hey, but it just plays songs from the same album. I have like 1,000 songs. How come it's always playing from the same album? Well, you would expect clusters to happen, birthdays to happen together, the shuffle to choose things together. So people complained. So Steve Jobs said, I'm going to make, and he did, he made the iPod shuffle less random. Yeah. So people thought it was more random.
The interesting thing about the gambler's fallacy and all that, to me, is that we're sort of talking as if it's a lack of understanding or knowledge of probability that makes people behave like this, and that's a factor. But the reason people don't know about it is they don't seek that knowledge because they don't, in the first place, believe that they are the victims of chance in the world. They actually believe that Caesar is choosing Caesar's head. Most people in the world believe that their behaviours and the things they say influence the universe.
Well, it's built into our language, isn't it? You hear it, it's meant to be.
Oh, I can't believe it's fate. Sorry to be a bit solipsistic, I am writing a musical of Matilda, and 10 years ago I wrote to the Dala estate to ask for the rights of Matilda because I thought it was a great idea, and then 10 years later the RSC said, do you want to write this song? Totally coincidental, and it's very hard to talk about that without engaging in the idea that it's the coming together of a fatalistic, which is absolutely absurd, and the self-importance you'd have to embrace to think that the universe is somehow, over that 10 years, God or someone's been sitting up there going, no, give it another couple of years. The Dala estate's not quite ripe. I mean, how absurd, and yet the instinct is massive, isn't it, to say, oh, we met, what are the odds that we were going to meet that night if you hadn't have done that and I hadn't have done that? And that's true, it's extremely low odds, but our instinct is to explain it by saying, well, it's fate, it's meant to be.
And I suppose this is also politically, there's a risk perception is very important, isn't it? Let's say that you want to make the argument that nuclear power is safer than coal-fired power stations. That understanding the risk associated with potentially catastrophic events, or flying, as you said, Tim, it's a common phobia when it's actually statistically extremely safe. So is it worth trying to overcome that kind of irrational fear? Because it is important if you're talking about whether to build nuclear power stations or whether to fly on planes or cars or trains.
Yeah, I think it's really important.
It's the most crucial thing. Yeah. I mean, it's so important. And if you're wondering, nuclear power is much, much, much safer than coal power. Just to be clear.
Often people say, what is it about maths that people should learn that will really help in your lives? And I don't think it is the ability to count or to calculate, because we can use a calculator for that. I think it is the ability to understand randomness.
And that brings us to the end of the show. On this, I'll give you some of these as well, Brian. These are the favourite numbers of the audience. We asked the audience what's your favourite number and why. We got a broad range of, I would say, some very fine nerdery, some definitely interest in mathematics, and some just absurdist, I think would be the polite way of saying that. Just 7, because it's my favourite film and I like to think that's how I'd live my life. What?
-1. Because I couldn't decide between E, I and pi, so I thought I'd go for E to the I pi. Which is superb. That's quality. Audience quality there.
664, the neighbour of the beast. Now... What I particularly like about that is I have heard that joke before, but it's been 665 or 667. But Jason Seymour very cleverly thought, hang on a minute, that's not how it works with neighbours. You have odds on one side and evens on the other. So well done for finally having a numerically accurate version of that joke.
In hell, all streets are triangular, so it actually skips 3.
8, because it is well balanced and symmetrical, and when laid on its side, has infinite possibilities.
Alex, I know when we said we'd collected these earlier, you said you wanted to take them away afterwards to observe them. Why is it interesting to you?
I'm interested in numbers and also cultural differences and approaches to numbers, and there's no reason why we should have a favourite number, but we all do, and so I'm kind of fascinated as to why.
Tim, do you have a favourite number?
I mean, if I had to choose a number, it'd be 7, because my wife and I are both born on the 7th, and it's a lucky number, and it's... I'll say that. Oh.
So the chances of that are what, about 1 in 250?
No, not the same day.
Something like that.
1 in 30.
Oh, yeah, because it's so it's not that special.
No. I've never claimed it was special.
So, that is the end of the show. Hopefully at the end of the show you know more than you did at the start, but of course there is the possibility that in fact you've learnt how much you didn't know that you didn't know, and therefore the pie chart of what you know is smaller than it was 27 minutes ago. Sorry about that, but we're now going to give you 167.5 hours to do your revision.
Thank you to this week's guests, Tim Minchin, Alex Bellos and Matt Parker. Next week we'll be joined by Alexis Sale, and we'll be discussing just how ridiculous philosophy is. That's not obviously what we'll be talking about. We will be discussing philosophy and its importance in culture, I think. Look at you living in Plato's cave with all your shadows of whatever things that shoot out magic. And I recommend Plato's Republic, a quick flick through Tractatus Logico Philosophicus, and a little bit of the cartoon guide to Leibniz, which I will be lending to you, Brian Cox. And if you find those too difficult, may I recommend Peanuts with Charlie Brown and Snoopy. So, which is actually genuinely very, very existential, but you think Calvin and Hobbes is more existential.
Yeah, but I haven't read any Charlie Brown, so...
It is a more difficult text. I would agree. Yeah, definitely. Goodbye.
If you've enjoyed this programme, you might like to try other Radio 4 podcasts, including Start the Week, lively discussions chaired by Andrew Marr, and a weekly highlight from Radio 4's evening arts programme Front Row. To find out more, visit bbc.co.uk/Radio 4. This is a download from the BBC. To find out more, visit bbc.co.uk/Radio 4.
Welcome to the Infinite Monkey Cage, a science show that offers no guarantees due to the uncertainty of the world and the universe beyond it, both statistically and in a quantum mechanical sense. So this all could be conjecture, but good, solid, empirical conjecture nevertheless. I'm Robin Ince.
And I'm Brian Cox. This week we're going to be looking at randomness, probability and chance. So in the absolutely literal spirit of one possible meaning of the potentially infinite set of meanings, both real and imagined, of Infinite Monkey Cage, we took a tombola wheel with all the letters of the alphabet on it, spun it...
First round.
Well, our first guess is a 1 in 23 chance of having a number 1 single, a 1 in 47 chance of refusing to go on stage if he has a veruca or a corn, but a 1 in 3,975 chance of saying, the thing about my crystal is that without it, my chakra just goes haywire. Now, as a composer of the new musical of Roald Dahl's Matilda and about to embark on an arena orchestral tour, rationalist musician and comedian Tim Minchin.
Our other guest is one of the few people to have written a book on mathematics and ghostwritten the autobiography of a world-famous footballer, though Bertrand Russell did co-write Principia Mathematica and attempted to go
21 times, noted down each letter, and created a title. It was...
The Infinite Monkey Cage. What are the chances of that?
1 over 26 to the power of 21.
Yeah, and I should actually be honest and say that Infinite Monkey Cage wasn't the first set of letters that came up. The first one was actually you and yours, but that seems ridiculous. To help us discuss randomness, probability and chance, we kept with the theme and pulled names out of a hat to decide who the guest would be. And then we decided it wouldn't really work with our guests Lindsay Lohan and the Lord Privy Seal. Anyway, we couldn't get the Lord Privy Seal's number, and also it turned out it's the hat used by I'm a Celebrity, Get Me Out of Here. So Lord Privy Seal's going to be pretty exciting in that locum.
It'll be heads 50% of the time, it'll be tails. So once we have a mathematical language, we can understand, where probability is going to go in the long term.
One of the problems with once it actually gets to numbers, generally, there is something that bamboozles the human brain right from the start. What is it? What do you think it is about the human brain that makes, for some people, the understanding, the comprehension of the meaning of numbers?
Well, there are two things. One is numbers and one is probability. I think lots of people, mathematicians, understand numbers. Lots of people here will understand numbers. But probability is really, really difficult to understand, and mathematicians, it's full of pitfalls and mistakes. So this idea that I might come along and be able to explain probability to you...
To write an autobiography of Nobby Styles. It's the author of Pele and Alex's Adventures in Numberland, Alex Bellos.
Alex, I suppose at the simplest level, probability is the study of chance. And I suppose the natural reaction to that is to think, well, chance, completely random events, how can you possibly study it? It must be entirely random. So how does a mathematician begin to study chance?
Well, that's the thing. We can't predict the future for one event. So if there's something that's got a 50-50 chance of happening, tossing a coin, we don't know what's going to happen. But if we were to take 1 million events, toss a coin 1 million times, we can be pretty sure that round about 50% of the time,